problem 3, again, we have a wire that's creating a magnetic field. For part A, when the switch is first closed, current in my original coil is going to flow that way, I1. As that current grows from 0 to some steady state value, the magnetic field created by that current is also going to grow. I use my left hand wire grabby rule to determine the direction of that magnetic field. If I grab the first coil of wire with my left hand, thumb pointing up the front of the wire, gives me original magnetic field lines that are pointing in that direction. So for part A, number 1, my second coil feels gaining magnetic field lines that point to the right. Again, they're gaining because as the current grows from 0 to some value, the magnetic field is also growing from 0 to some value. So my second coil feels gaining rightward pointing arrows. It is going to oppose the change, and to oppose the change, my second coil is going to create arrows that point to the left. So it is going to create leftward pointing arrows to oppose the change. In so doing, it's going to have a current that is going to be running down the page, across the resistor in that direction. I can tell that because I go to grab that second wire with my left hand, fingers pointing to the left inside the coil, gives me my thumb pointing down the page. For part B, it is one of my favorite problems. Now the switch has been closed for several minutes. Since the switch has been closed for several minutes, I know that the current in the first coil, I1, has reached its final value, its steady state value. Therefore, the current is constant in my first coil. Since the current is constant in the first coil, the magnetic field created by that current is also constant. My second coil therefore feels a constant magnetic field pointing to the right. However, Faraday's law does not say that the presence of a magnetic field causes induction. Faraday's law says that the change in the magnetic field causes induction. Since there is no change in the magnetic field, I have a constant magnetic field pointing in that way. Therefore, there is no change, and no change will yield me no current in the second wire. For part C, now I'm opening the switch. As I open the switch, the current in the original coil, I1, will decrease from some value I1 to 0. As that current shrinks away to nothing, the magnetic field created by that current will also shrink away to 0. Therefore, my second coil feels a loss or losing magnetic field lines that point to the right. It is going to counteract the change. Since the change is losing rightward pointing vectors, my second coil is going to create rightward pointing vectors to oppose the change. So my second coil will create red vectors that point to the right. Now I can use my left hand wire grabby rule to determine the direction of the current when I grab the second coil with my left hand, fingers pointing to the right in the direction of the red magnetic field lines. I see that my thumb will be directed up the page here, meaning my current is running across the resistor from left to right